In the last video, we saw that the limit as theta approaches 0 of sine theta over theta was 1, provided theta is in radians. Okay, now we'd like to look at some related limits. Some of them are important. The first one we see here is important in the derivation of some derivative formulas. The others are just applications of this limit. So let's take a look at this limit. The limit as x approaches 0 of cosine of x minus 1 over x. This limit may be stated in your book as the limit as x approaches 0 of 1 minus cosine of x, but I found this to be the most helpful when we're talking about the derivatives. Now, a common tool that you can use to take a limit is to use the conjugate. So what we might do, and this you've seen in trigonometry class, is that to simplify an expression, multiply it by the conjugate. All right, we form the conjugate by changing the sign on the second term. So we multiply instead of by cosine of x minus theta, cosine of x plus theta, and of course we multiply by that over itself, so we don't change any values. All right, if we do that, this becomes the limit as x approaches 0 of, now let's see, when we multiply these together, we'll get cosine times cosine. Oops, this is cosine of x, it should be. All right. Cosine of x times cosine of x, which is cosine squared of x. And then cosine of x times 1 is cosine of x. Cosine of x times negative 1 is negative cosine of x. So those add out. And then we'd have negative 1 times 1, which is negative 1. And this will all be over x times the quantity cosine of x plus 1. Okay. All right. Okay, now the cosine squared of x minus 1, or cosine squared of x minus 1, remember that sine of x squared plus cosine squared of x is equal to 1. So sine squared of x is equal to 1 minus cosine squared of x, and that means that the opposite of sine squared of x is equal to cosine squared of x minus 1, which is precisely what we have here. So this expression is going to be the same thing as the limit as x approaches 0 of the opposite of sine squared of x over x times the quantity cosine of x plus 1. And notice we can write that as in two factors. We can write this as the limit as x approaches 0 of sine of x over x times a negative sine of x over cosine of x plus 1. And of course, if you just multiply that out, you'll see we come up with that same expression. And then we could take the limit of the product as the product of the limits. That doesn't work for derivatives, but it does work for limits, remember. And so we have the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of negative sine of x over cosine of x plus 1. This limit is the same as the limit we have. It's just stated in terms of x rather than theta. So assuming x is measured in radians, this limit is 1. We'll just always make that assumption. And this limit, well, as x approaches 0, sine approaches, well, this is a continuous function, so we could simply evaluate it. So this would be the opposite of sine of 0 over cosine of 0 plus 1, which is going to be 1 times the opposite of 0 over 1 plus 1, and of course that's 0. So this limit turns out to be 0. Okay, question? All right, let's go on to another limit. This is the limit as x approaches 0 of tangent x over x. All right, well, this would be the same thing as the limit as x approaches 0. Tangent is sine over cosine, so this would be sine of x over cosine of x times 1 over x. And this would be tangent of x times divided by x, or times 1 over x. And this we could rewrite as the limit as x approaches 0 of 1 over cosine of x times sine of x over x. Now we have the product of two expressions, so assuming the limits exist, I can take the limits separately and multiply them. So this would be the limit as x approaches 0 of 1 over cosine of x times the limit as x approaches 0 of sine of x over x. And again, if this is the same limit that we have up here, it's stated in terms of x rather than theta. So this limit is 1, assuming that x is measured in radians. And this is a continuous function, so it's 1 over the cosine of 0, and the cosine of 0 is 1. So this is 1 over 1 times 1. This limit of tangent of x over x as x approaches 0 is 1, again, provided we're working in radians. All right, here's another example that I'd like to show you. And this one, a friend of mine has showed me something, and they ask if you should be given credit for this. And a student should, in arithmetic class, suppose that a student looked at this expression, and they were asked to reduce it. They were asked to reduce this expression. And so what if they went, all right, okay, so when they reduced that expression, they did get 1/4, which is the reduced version of this, but their method of doing it was completely wrong. Should they be given credit for it? Okay, the thing is that the reason why I say this is because, well, of course they shouldn't be. They don't know how to reduce something, and that's the idea. It's not to just get one right answer; it's to be able to reduce things, and that's the same thing here. Is that happens, and that we have to worry about, all right, because there's a way that's completely wrong, all right, but gives us the correct answer, and that is this. Now notice, this is, I want to specify, this is wrong. This is wrong. It's not sound thinking. It's thinking that has fallacies in it. Okay, as we take the x as x approaches 0. Okay, and they would write this. Just by taking the 3 out of sine of x. But is sine of 3x equal 3 sine of x? And the answer is no. They're not the same. Sine of x and sine of 3x are not the same. So let x be pi over 2. This would be the sine of 3 pi over 2, which is -1, and this would be the sine, 3 times the sine of pi over 2, which would be 3 times 1. They're not the same. All right, what is it? What is the sound thinking way of doing this? Well, the sound thinking way of doing this is to do a substitution. Okay, and so here's what I'm going to do. Let's look at this limit here. The limit as x approaches 0 of sine of 3x over x. Okay, let's look at that limit. And now let's make this substitution. Let's let v be equal to 3x. So this is going to be the sine of v. I'll fill in the blanks as we go along. This will be the sine of v. Okay? All right, well, if v is equal to 3x, that means that x is equal to v divided by 3. So what we'd have in the denominator instead of x would be v divided by 3. All right, and if we take the limit as x approaches 0 of v, that would be the limit as x approaches 0 of 3x. That would be 0. So this would be the limit. Now we have to state it in terms of v. Here's as x approaches 0. Oops, let me. All right, this would be as v approaches 0. We have to be careful because sometimes they wouldn't approach the same thing. All right, and now let's take a look at that. Notice dividing by v over 3 is like multiplying by 3 over v, so this would be the limit as v approaches 0 of 3 times the sine of v over v, and this would then be the limit as v approaches 0 of 3 times the limit as v approaches 0 of the sine of v over v, which is just this above limit restated in terms of v instead of theta. So this is the limit of a constant, so it's the constant 3, and this limit turns out to be 1, assuming that we're measuring things in radians. So this limit turns out to be 3. All right, again, taking this 3 out of here like that gives us the correct limit, but for all of the wrong reasons. This is the way to approach this on a sound footing. Let's take a look at one more limit here, and this is the limit. We'll use the limit from above, all right? And this is the limit as x approaches 0 of sine of 3x over sine of 5x. All right, what I'm going to do with this limit is let's multiply this by the top and bottom by 1 over x. Okay, if we do that, then we'd have the limit as x approaches 0 of sine of 3x over x divided by sine of 5x over x. And I won't go through all the details, but this is going to be the limit of the quotient is the quotient of the limits, provided the denominator does not go to 0, sine of 3x over x divided by the limit as x approaches 0 of sine of 5x over x. This limit we saw up above was 3, and by the similar techniques, this limit would be 5. Okay, so this limit would turn out to be 3/5.